Hello. So today I'll explain to you how I did the approximation of Expectimax with AI. So hello, I'm Raphael, and I had fun in the last weeks just messing around with the code from Royal Air Analysis that's it made in the Discord, and I'll explain to you uh, quickly how I did it, why, and how you can help me doing it, and maybe how we can go from there, where we can go from there, like new statistics and new visualization, maybe new projects with this. So here are let's say the main things, or the outline. Here's the outline. So Expectimax is useful but very slow, as as I saw in the last days. So I try I try to run it, and it is slow. It's the reason why I try to approximate the thing with AI, because I know it's very useful to do analysis with it. But if you want to try something and it takes days to compute, it's not great. So if you can approximate it, it's better. What I had as a thought is that maybe I can represent part of the problem with fixed size vectors. Why fixed size vectors is because if you do AI, usually you want your data represented as a bunch of input of a fixed size, and usually one thing to guess, so a number or a category. Here we have the number because we have the utility function from the Royal code base. So it's the canonicalize, not in this, I don't remember. Give me a second. Canonicalize wins utility function. So this is essentially the number we'll be trying to guess. And how can we represent this problem with a fixed size vector? By fixed size vector, I mean imagine like give me a second. Imagine like a table like this. So this is a data set. A fixed size vector just means that there's a fixed number of columns. So column 1 and the label. Label usually means the thing that we want to predict or learn. So here there are many columns. This is an example. So values like this. Okay. So this is not really important, but just so you know, fixed size vectors. Just imagine like an Excel spreadsheet. You know, fixed size number of columns, many rows, fixed number of columns. And so that's it. Had the very interesting idea to split the problem at the choice of the pounds, you know. So if you have a board state, a fixed board state, and you have, let's pick one online. So here, let's say I'm I play the darker pounds, and I have the throw of 2, like I rolled 2. I have I can play here or there. So if I want to represent this data wise, I could do it like having a list of pawns to play. So the one that's not yet played, you know. Okay, yeah, they start here. So the one that's not yet played, so maybe a new pawn, and the one that's on the board. So that's 2. two moves, but that number could change. Like if I had if I had no pawns left to play, it was my last pawn, or I'm the white. So if I throw a one, I just have one pawn to play. What where am I going with this is that depending on the situation, maybe I have 3, 4, 7 pawns to play. So that this is not fixed. It's not a fixed size vector. So you cannot do this if you want to have an AI or a data set that's suitable for AI. And since that's our goal here, we cannot do that. But so that's it. Had the brilliant idea to analyze each move individually, and it works very well because not I think, but I know that the code base for Expectimax works exactly like this. So it tries to capture the best move by going through each move individually and then setting an utility value to each move. So we could like split this problem into like iterating each possible move and then trying to guess the utility value, which is the part that is very long to compute essentially, because there's like a tree search or tree traversal algorithm with many paths, because at each step you want to guess the next step and the next steps and then do some statistics to get the answer. So some AI. Like I told you, I want a fixed size vector and I want to do maybe AI with it. So first step is to gather and prepare data. And maybe this is a little early, but I chose LightGBM to do the AI. But let's start with the gathering. Gathering for me, if you followed in the Discord, you may know about this, but if not, I just did like a simulation in Expectimax Approx. So what it does, it's starting many threads in parallel with two random agents playing one against another, and at each step, at each move, this generates essentially an interesting board state and a valid board state. So I ask Expectimax its opinion on each of the possible moves, with each possible rolls between 1 and max, which is 4. And then I record it. I record what the move is, so the board state, the roll, the current roll, the position in X and Y of the pawn that is analyzed, the state of whose turn is it to play on the board, the utility, so the answer to the utility function, the part that's slow, what's the score of all the players, how many ties they have left to play, sorry. And this is the ranking. I added ranking afterwards. For now it's not very useful, but it's instead of having the data represented as a utility function or just the number, we have it also as the rank at which the utility function, where the utility function ranked the current move. So instead of just having the number of the utility function, the value, we have where the move was ranked compared to the other moves that were available. So with our example of earlier, maybe this the move of getting a pawn out was higher ranked than getting this pawn to move there. So we'd have in rank 1 for the new pawn to be moved there, and the 2 for the one to be moved there. So it's dependent on the board state that's analyzed at this moment. It's a higher level data point because you need to know about other moves, which is not the case. Well, it's not easily available otherwise in the data set because you just have a row is one pawn to be moved. So I do random board states. Well, it's random, but it's valid. So I should write here get valid random state. Here it's random because it's a little faster to code and to have working. So we have random players playing the game. It's a valid state, and I ask Expectimax to give me um, the scoring. But Expectimax is very slow, so that's where you can help me to generate more data. I've left my computer running for like a week nonstop now, and it's computing for at this moment. Well, I stopped it before recording, but at this moment I'm trying to generate data for Expectimax of depth 8, which I can generate like 2 or 3 moves per second, so it's very slow. I expect to have at least 1 million rows if I want to have a good data set for this. So dataset and stats. With the dataset that this produces, we can do interesting stats. So I brought that into it outputs as CSVs, as you can see. I have something to highlight the colors of the columns. So white is white, blue is blue, you know, red is red. I think you understand. But sorry, I'm a little nervous. I'm difficulty breathing. Maybe I should breathe more. So yeah, okay. So I have CSV there, and using this CSV, I created a Parquet file. Parquet file are like CSVs, but in a binary format, and they contain data about the types of the columns instead of being all text in CSV, like in CSVs. CSV is just a text file with the comma separated values. So yeah, I have this prepared data set that takes one or many CSVs and concatenate them, and then I type them properly, and then I write them to the disk as a Parquet file, which then I read. I do something else here, which is maybe a little subtle, but it's very big. I do this, which is a little complicated, but it essentially transforms this thing, which is the game state, as a string to a bunch of columns where each part here is a cell, and it's encoded in -1, 0, or 1. 0 meaning empty, -1 meaning light, I think, and dark being 1. I'm not sure. So one or the other. So maybe -1 is reversed with 1. I don't remember. If you can look at my code, maybe you'll figure it out. But it's there. So it's light. It's light that's -1, and dark that's 1. So yeah, that's useful. So instead of treating strings here, I'm treating a bunch of numbers, which is what my AI expects. But I don't really use it in the data visualization phase, but it's there. As you can see, game 0, 1, 2, 3, 4 is like all columns that are numbers. So you can see it's like a status. This is an aggregate statistics about the state of all the columns in my dataset. so like you said, like you saw before, like the role, position in X and Y of the pawn that's analyzed. Light turn, is it the turn of the light player, the dark player? So it's pretty even. Utility function, this is the interesting part that we're trying to solve for. Light score, dark score, light left. You get the gist. And this is the state of all the possible cells in the on the board. Though they are 20. There's 20. This is it, in the statistics format. We can see the whole data set here, what it looks like. Utility, we have values, what turn is it, how's the game going, etc. And finally, the part that's exciting here, maybe Diego on Discord will like this. It's the aggregate values here for this heat map. Sorry for this. I'm nervous and I'm playing with something and it's making lots of noise for you, I think. So I'll stop. Okay, so I'm doing pivot tables. Pivot tables is essentially doing aggregates. Here is the average. So it takes the average of X and Y that are here. So the position for each starting locations, and uses this for use the utility for the value in the cell. So just so you know, this is very average, so we're losing lots of data doing this because this is just the average. We can see that here the let's say the utility function is usually lower in the last cell of each side. This doesn't mean that the AI will never pick it. It's just that it happens to in how many games is it? Where I don't know how many games, but it's 1.68 million different position in games, so 1.6 million rows here for our data set. This is where it was the lowest scores, but it doesn't, again, it doesn't mean it's never playing it. If you were to just use this as is, you would never ever come out at the end unless it was the last possible move. So using this as an average may be interesting to try, but maybe I suspect won't be very good at the game. But it indicates for me like how the AI thinks. We can see it doesn't really want to leave this centerpiece, which is normal, we know, as the players. It's expected. Here it's the same heat map, but just for rows of 1. So, like, if you roll just a 1, so I slice the data set for just using the rows of 1, and we can see how Expectimax of that 7 thinks about a roll of 1 usually. So this is for all rolls together, so rows of 1, 2, 3, 4, but this is just for rows of 1. Maybe using those heat maps, maybe I could release the pivot table, like the original values for each of the rows. Maybe that would be better, a better approximation. I doubt it would be very good, but I mean, maybe it would be good to create a I don't know, utility function for the code. I don't know. So I'm just explaining. So I did this for the rule of 2, rule of 3, rule of 4 here. It's important to know that there's a missing row because there are no data points past this cell on the board, because you cannot move with a row of 4 past this cell. So I have no data to plot. So it's just not showing up. And I did something else which I didn't really share here on the Discord. This is this same heat, well, not same heat map. It's a heat map like the ones before, but it's for ranking of pounds. I didn't really rerun this, so the title isn't correct, but the graph is. So instead of using the utility function as the value for the pivot table, I use the rank value. This means that we see usually where the Expectimax ranks the move when the pawn is at position. So the lower is usually better. So lower, what I mean by lower, I mean what's nearer to 1 is the most picked move. So a black square here, well, the darker the square, the lower the value, so the most expected to be picked it is. I don't know how to explain it better. Maybe it's more interesting to see as I've sliced for different rows. So as you can see, maybe not maybe, but it's pretty sure that the value here is 1. So it's pretty much the spot that you want to move when you have a 1. If you have a pawn here, please do move there because there's the rosette there, so you want to replay. So this is very interesting too to see. It doesn't really want to move with a rule of 1 from there to there, so this is interesting too. Maybe we could try this as a decision function, like for approximating the Expectimax decisions. Yeah, this is pretty much it. If you have other ideas of things that you want to visualize, or if you have other questions, I will maybe do another video to explain how I did the AI stuff. So maybe another thing that's more in depth. I wanted to go like quickly and not in surface, you know. Sorry for having difficulty talking English. I don't talk in English often, so sorry. A little late, but I'm sorry anyway. Bear with me, please. So yeah, I want to like explain to you, and I want you guys to participate with me because it's very interesting. I would love that you check out the code so that you can help me generate some data for Expectimax 8 depth. My goal would be to have an AI that approximates the depth of 8 instead of 7 so that we can beat the 7 with the AI. That would be the ultimate dream. For now, my AI does not beat the Expectimax 7 even with the approximation. I think it's 3% less good over a couple of games. So yeah, thank you for listening. See you later, alligator.